Hello, this is Leo Chulo from the Channel 119 News, and this is a special report on the chemistry behind deep-sea diving and its effects on humans. Professor Mike Richards of the North American Diving Society will be joining us to discuss the basic principles behind water pressure and its harmful effects on divers while explaining why marine mammals can stand intense water pressure for long periods of time. I moved up because I thought I should be closer to my viewers. Without further ado, here is Professor Mike Richards. Hello, nice to have you on the show, Mike.
It's good to be here, Leo.
So what do you have to share about the water pressure today with us?
Well, Boyle's law states that at a constant pressure for a fixed mass, the absolute pressure and the volume of a gas are inversely proportional. Henry's law states that at a constant temperature, the volume of a given gas that dissolves in a given type of and volume of liquid is directly proportional to the partial pressure of that gas in equilibrium with that liquid.
Interesting. Would you care to demonstrate that with us?
Of course not. So, in Henry's law, nitrogen is 78% of the standard atmosphere. Nitrogen's partial pressure then at sea level is 78% of 1 atmosphere, or 0.78 atmospheres. The solubility of nitrogen at sea level is 25 Celsius and can be determined using Henry's law, which can be shown like this.
Interesting.
Boyle's law, for example, if a balloon with a volume of 2 liters is filled with a gas at 3 atmospheres, if the pressure is reduced to 0.5 atmospheres without a change in temperature, what would be the volume of the balloon? Well, by using P1V1 equals P2V2, we can use an equation like this to solve for this.
Very cool. Very interesting. Wow. Now how about the effects water pressure has on divers? Many do not realize the strict limitations divers must deal with.
You're right. Water pressure restricts divers from going to certain depths. The bends is a nitrogen solubility problem. As scuba divers dive to deeper lengths, the pressure of air they breathe must match the pressure of the water around them. This increase in air pressure increases the solubility of nitrogen. If the high pressure making nitrogen dissolve is rapidly lowered or removed, the nitrogen becomes insoluble and returns to its gaseous state as gas bubbles. These gas bubbles are trapped in the tissues and bloodstream in a process called aerobolism. The bubbles can be transported to vital tissues such as your brain, where they cause serious problems. Understanding nitrogen and solubility are key to making sense of the phenomenon known as the bends.
So, are there any mammals that can withstand this pressure?
Yes, one in particular is the Weddell seal.
Have you had any past experience working with these mammals?
I've had the opportunity to study the diving techniques of the Weddell seals, and I have learned that this mammal can use various methods to stay in deep water for such a long time. Research shows that they have the ability to collapse their lungs while in the water, so they don't require as much air. Weddell seals' metabolism is relatively constant during deep water dives. So another way to compensate for functioning with the lack of oxygen during an extended period of time must exist. Seals, unlike other mammals, such as humans, can undergo anaerobic metabolism. For these extended dives, which causes a buildup of lactic acid in the muscles, the lactic acid does not enter the bloodstream. However, until after the animal has surfaced, this is done by constricting the capillaries from the muscles to the veins. But a longer recovery time is needed though, which in the long run may be less efficient than quicker aerobic metabolic dives.
See, Mike's really smart. He knows this stuff. So how how long could these animals stay submerged under the water?
They could stay underwater for about 45 minutes to an hour using these techniques.
So humans probably could not do that.
No.
Since there's extreme conditions underwater, what could divers do to prevent decompression sickness?
Well, it is not completely avoidable, although there are a few ways that you can try to minimize the risk of decompression sickness.
All right.
One step is to try to dive within depth and time limits. So you don't want to go farther and extend farther than you know that you can go.
Okay.
You want to ascend slowly from every dive. So you don't want to go right up to the surface as fast as possible, because it can really mess with the oxygen and everything going to your brain. You also want to perform a safety stop before surfacing. So like I said before, you don't want to go right up to the top and just get right out of the water. You want to relax in the water by the surface a little bit and get used to the air, the less pressure. And you want to avoid high altitudes after diving. So you want to try to not go in an airplane or anything like that. You want to try to stay on the ground and pretty much relax.
So you need a lot of rest after you dive then?
Yes, you need rest. And another way is to just stay hydrated. You want to make sure you have enough fluids in your body. These are all pretty good ways to minimize your risk of decompression sickness or the bends.
Okay. Well, it's good to know there's ways to keep safe while diving. Thanks for your time, Professor.
Anytime, Leo. Thanks for having me.
Well, there was Professor Mike Richards on water pressure and deep sea diving. I hope you learned as much as I did. Thank you for tuning in.
Aside football rules!
Alright, so after our research, we concluded that any projects to obtain knowledge about our oceans is worth it. Deep sea diving is a first-hand account of exploring the ocean, and we as a race know very little about the oceans on this planet. We know more about the cosmos and the outer space. So any research put into it is worth it. Any knowledge obtained through it is beneficial to us. And
as Leo said, since we don't really know much about the oceans, we don't really know what's beneficial to us down there, but there's also probably unlimited knowledge still that we have yet to explore, and that's really what humans are here to do. And I believe that we should keep doing this, because it shows a great benefit to our society in that there could be resources down there that can help us out as a race. It can help us to learn more about the Earth, which we have been living here for hundreds and thousands of years. We have no idea what really anything is on our planet. We have no explanations, and unlocking secrets in the bottom of the ocean might allow us to understand that more.
yeah, like Mike said, it's definitely beneficial to us to research into water pressure, how to get beyond the limits of intense water pressure at great depths in the ocean. It's definitely not a waste of money, and through research, it's definitely possible to go past those limits and get deeper down in the ocean and see what's down there.
Yeah, any amount of money that we would have to spend is obviously worth obtaining more knowledge for humans, and it's obviously very valuable information. We don't really know what's down there. The possibilities are endless, and really we just have to try to keep working on this, I think, and I think it's truly important for us to know more about our Earth,
our planet. It's definitely worth it, and I can definitely foresee more exploration in the oceans happening in the future. Definitely our Navy is going to put more time into seeing what's down there, more projects to go to greater depths. we said, it's definitely not a waste of money. It's definitely worthwhile going down and seeing what's down in the great depths of our ocean.
So thanks for watching our presentation, and that's all we have. So see ya.
Thank you.